A shared neutral exists between a multi-wire branch circuit serving master bedroom receptacles and a ground fault circuit interrupter, or GFCI, circuit serving the master bathroom, all within a single conduit run. This setup can lead to nuisance tripping of the arc fault circuit interrupter, or AFCI, breaker protecting the bedroom circuit. This is due to imbalanced current potentially emanating from the ground fault circuit interrupter, or GFCI, circuit. Several solutions exist. Firstly, separate neutral conductors. An additional neutral conductor can be installed inside the conduit, thus isolating the neutral serving the bedroom circuit from that of the ground fault circuit interrupter, or GFCI, circuit. A new junction box can be installed at the termination point to facilitate splicing the newly installed neutral conductor into the bedroom circuit. Secondly, consider using a two-pole arc fault circuit interrupter, or AFCI, breaker. It's important to contact the manufacturer of the commercial panel in question to ascertain the availability of two-pole arc fault circuit interrupter, or AFCI, breakers suitable for installation within their panels. If such a breaker exists, installing it to protect the bedroom circuit would independently provide protection for both the bedroom and the bathroom circuits. It is not recommended to run undersized wires or exceed conduit fill capacity. About the use of arc fault circuit interrupter, or AFCI, breakers in commercial panels. Arc fault circuit interrupter, or AFCI, breakers are generally designed for use in residential applications. To determine compatibility, one must consult manufacturer specifications and relevant local electrical codes to verify whether these breakers are listed for use in commercial panels. It is always advisable to consult with a qualified electrician or engineer when working on commercial electrical systems. To further elaborate on the separate neutral conductor solution, consider the implications of current flow in multi-wire branch circuits. In a properly functioning multi-wire branch circuit, the neutral conductor only carries the unbalanced current between the ungrounded conductors, also known as hot wires. If the loads on each leg of the circuit are perfectly balanced, theoretically there would be no current flowing in the neutral conductor. However, in practice, perfectly balanced loads are rare, hence the need for a neutral conductor. When a ground fault circuit interrupter, or GFCI, circuit shares the neutral with another circuit, any current imbalance caused by the ground fault circuit interrupter, or GFCI, device will be seen by the arc fault circuit interrupter, or AFCI, breaker on the other circuit. Arc fault circuit interrupter, or AFCI, breakers are designed to detect very small current fluctuations that could indicate an arc fault, a potentially dangerous condition that could lead to a fire. Therefore, even a small amount of unbalanced current from the ground fault circuit interrupter, or GFCI, circuit can cause the arc fault circuit interrupter, or AFCI, breaker to trip unnecessarily. Pulling a separate neutral conductor for each circuit eliminates this potential for interference, ensuring that each circuit functions independently and that the arc fault circuit interrupter, or AFCI, breaker only trips in response to actual arc fault conditions on its dedicated circuit. When installing the new neutral conductor, it is crucial to use the correct wire gauge and insulation type as specified by the electrical code. The neutral conductor must be sized to handle the maximum anticipated current load of the circuit it serves. It must also be properly insulated to prevent shorts or ground faults. The new junction box used for splicing the neutral conductor must be appropriately sized to accommodate all the conductors and connections without overcrowding. The connections themselves must be made using approved methods and materials such as wire nuts or crimp connectors to ensure secure and reliable electrical connection. Now considering the two-pole arc fault circuit interrupter, or AFCI, breaker option, it is important to understand how these breakers function and how they differ from single-pole arc fault circuit interrupter, or AFCI, breakers. A single-pole arc fault circuit interrupter, or AFCI, breaker protects a single 120-volt circuit. It monitors the current flowing through the hot wire and the neutral wire, looking for any abnormal fluctuations that could indicate an arc fault. A two-pole arc fault circuit interrupter, or AFCI, breaker, on the other hand, protects two 120-volt circuits that share a common neutral or a single 240-volt circuit. It monitors the current flowing through both hot wires and the neutral wire, looking for arc faults on either circuit. If an arc fault is detected on either circuit, the two-pole arc fault circuit interrupter, or AFCI, breaker will trip, disconnecting both circuits from the power supply. Using a two-pole arc fault circuit interrupter, or AFCI, breaker in this scenario can solve the nuisance tripping problem because it treats the two circuits as a single entity. Any unbalanced current from the ground fault circuit interrupter, or GFCI, circuit will be seen by both poles of the breaker, and it will only trip if there is an actual arc fault on either circuit. However, it is important to note that two-pole arc fault circuit interrupter, or AFCI, breakers are not always readily available, and they may be more expensive than single-pole arc fault circuit interrupter, or AFCI, breakers. Furthermore, it is crucial to ensure that the two-pole arc fault circuit interrupter, or AFCI, breaker is properly rated for the application and that it is compatible with the electrical panel being used. When selecting a two-pole arc fault circuit interrupter, or AFCI, breaker, it is important to consider the voltage and amperage rating of the circuit it will be protecting. The breaker must be rated for at least the maximum voltage and amperage of the circuit. It is also important to consider the interrupting capacity of the breaker, which is the maximum amount of fault current that the breaker can safely interrupt. The interrupting capacity of the breaker must be greater than the available fault current at the point of installation. Another important consideration is the type of arc fault protection provided by the breaker. There are two main types of arc fault protection: branch or feeder, and combination. Branch or feeder arc fault circuit interrupter, or AFCI, breakers protect against arc faults in the branch circuit wiring, while combination arc fault circuit interrupter, or AFCI, breakers protect against arc faults in both the branch circuit wiring and the appliance cores plugged into the receptacles. For this application, a combination arc fault circuit interrupter, or AFCI, breaker is generally recommended as it provides the most comprehensive protection. Finally, it is important to check the listing and labeling of the breaker to ensure that it is approved for use in the specific electrical panel being used. The breaker must be listed by a recognized testing laboratory, such as Underwriters Laboratories, or OL, and it must be labeled with the manufacturer's name, model number, voltage rating, amperage rating, interrupting capacity, and type of arc fault protection. Regarding the note about not running undersized wires or exceeding pipe fill capacity, these are both critical aspects of electrical safety and code compliance. Undersized wires can overheat and cause a fire. The electrical code specifies the minimum wire gauge that can be used for a given circuit based on the amperage rating of the circuit and the type of insulation used in the wire. It is important to consult the electrical code and wiring tables to determine the correct wire gauge for each circuit. Exceeding pipe fill capacity can also cause problems. When too many wires are packed into a conduit, it can be difficult to pull the wires through the conduit, and it can also cause the wires to overheat. The electrical code specifies the maximum number of wires that can be installed in a given size of conduit based on the type of wire, the size of the wire, and the type of conduit. It is important to consult the electrical code and conduit fill tables to determine the maximum number of wires that can be installed in each conduit. In addition to the electrical code requirements, it is also important to follow the manufacturer's instructions for installing wires and conduits. The manufacturer's instructions may provide additional guidance on wire sizing, conduit fill, and other aspects of the installation. When in doubt, it is always best to consult with a qualified electrician or electrical engineer. Furthermore, let's delve into the nuances of ground fault circuit interrupter, or GFCI, and arc fault circuit interrupter, or AFCI, protection. Ground fault circuit interrupter, or GFCI, protection is designed to protect people from electrical shock. It works by monitoring the current flowing through the hot wire and the neutral wire of a circuit. If there is a difference of more than a few milliamperes between the current flowing through the hot wire and the current flowing through the neutral wire, it indicates that some of the current is leaking to ground, which could be through a person. In this case, the ground fault circuit interrupter, or GFCI, will trip, disconnecting the circuit and preventing electrical shock. Ground fault circuit interrupter, or GFCI, protection is required in many areas of the home, such as bathrooms, kitchens, and outdoor receptacles. Arc fault circuit interrupter, or AFCI protection, on the other hand, is designed to protect against fires caused by arc faults. Arc faults occur when electricity jumps between two conductors, creating a spark. These sparks can ignite nearby combustible materials such as wood, paper, or fabric, causing a fire. Arc fault circuit interrupter, or AFCI, breakers work by monitoring the current flowing through the circuit, looking for abnormal patterns that could indicate an arc fault. If an arc fault is detected, the arc fault circuit interrupter, or AFCI, breaker will trip, disconnecting the circuit and preventing a fire. Arc fault circuit interrupter, or AFCI protection is required in many areas of the home, such as bedrooms, living rooms, and dining rooms. The electrical code specifies which areas require ground fault circuit interrupter, or GFCI, protection and which areas require arc fault circuit interrupter, or AFCI protection. In some cases, both ground fault circuit interrupter, or GFCI, protection and arc fault circuit interrupter, or AFCI protection may be required in the same circuit. In this scenario, a combination ground fault circuit interrupter, or GFCI, and arc fault circuit interrupter, or AFCI, breaker can be used. Now, let's discuss the implications of using arc fault circuit interrupter, or AFCI breakers in commercial panels. Arc fault circuit interrupter, or AFCI, breakers are generally designed and tested for use in residential applications. Commercial electrical systems often have different characteristics and requirements than residential systems. For example, commercial systems may have higher voltage levels, higher current loads, and more complex wiring configurations. These differences can affect the performance and reliability of arc fault circuit interrupter, or AFCI breakers. For this reason, it is important to check with the manufacturer of the arc fault circuit interrupter, or AFCI breaker, and the electrical panel to ensure that the breaker is listed and approved for use in the specific commercial panel being used. The manufacturer's specifications and local electrical code should be consulted to ensure compliance with all applicable requirements. Furthermore, it is always advisable to consult with a qualified electrician or electrical engineer when working on commercial electrical systems. These professionals have the knowledge and experience to ensure that the electrical system is properly designed, installed, and maintained. Finally, let's consider the potential for future expansion or modifications to the electrical system. When designing and installing an electrical system, it is important to anticipate future needs and to provide adequate capacity for future expansion or modifications. This may involve installing larger conduits, using larger wire sizes, or providing additional panel space. By planning ahead, it can be easier and less expensive to make changes to the electrical system in the future. In the specific scenario described, it may be wise to consider the potential for adding more circuits to the master bathroom or bedroom in the future. This could involve running additional conduits to the junction box or using larger conduits to accommodate more wires. It is also important to label all wires and conduits clearly so that they can be easily identified in the future. By taking these steps, the electrical system can be made more flexible and adaptable to future needs.